Welcome to the video introduction of BatchGenie. In this video, I'll guide you through the key features of the add-on, helping you get the most out of your workflow. We'll start by exploring how to import textures efficiently. Then, we'll move on to rendering asset previews. And finally, we'll cover batch utilities that streamline your tasks. Let's briefly touch on some basics. BatchGenie can be found in the end panel inside the 3D viewport under its own tab named BatchGenie, as shown here. If you prefer, you can move it under the Tool tab by adjusting this setting in the Preferences. Here, you can quickly access the add-on preferences or visit the documentation website for detailed information by clicking these buttons. Every feature includes hover over tooltips, providing quick and detailed explanations directly within the add-on interface, making it easy to understand functionality without needing to leave the workspace. Additionally, some areas include a question mark icon. Clicking it will open a pop-up with more information and a link to the relevant section of the documentation. If you need more in-depth details or prefer written guides, you can always visit the detailed documentation on the website. Let's start with importing textures. We'll begin with a basic import using the default settings. I'll browse to a folder containing several texture sets that we'll import. As you can see, there are textures both directly in the root folder and in subfolders. Now that the import is complete, let's take a look at the results of the imported materials. Everything looks great. Now, let's dive deeper into the settings and explore some of the customization options. There are a wide range of settings you can adjust, and most of them are straightforward. But let's take a quick overview. The first two options determine what to include in the import, either files only in the root directory or also in subfolders. The Skip Existing option prevents importing duplicate materials. The Use Fake User and Mark as Asset options. Then there's an option to handle DirectX normal maps, which adds a conversion node so Blender can process them correctly. The Alpha from Base Color setting configures the use of the alpha channel from the base color texture. You can choose Auto, which attempts to detect the presence of alpha data but may impact processing time. If your textures use alpha from the base color, select Force On, which skips detection and connects the alpha channel directly. If you need to filter out unwanted textures, you can enter keywords here to exclude them. For example, to filter out DirectX normal maps, you could use DirectX or DX. Next, we have material settings and options for texture nodes, allowing you to fine-tune how materials are created. These two settings provide powerful customization for your materials. Replace Principled BSDF allows you to use any existing node group instead of the principled BSDF in your materials. Custom Attributes lets you set one or multiple socket attributes, such as color or values, during the import process. I'll go through these two settings in more depth in the next steps. And of course, there are the texture options, where you can select which texture types to import. Usually, having everything enabled works great for most projects. Now we'll perform another import, this time adjusting a few settings to see how the add-on handles more specific configurations. Let's say I want to import some leaf textures and set up the material to include additional nodes for handling leaf translucency and other effects. This is where the power of the Replace Principled BSDF setting comes in. In this example, I'll use a custom node group that I've specifically created for leaf textures, which handles translucency and other details such as color variations. Let's begin by selecting the folder containing the leaf textures. Then, we'll go down to the settings and choose our custom node group. Now, we can simply click on Import and see how the material turns out. It's a good start, but there are some additional things I want to configure during the import. If we go back to the folder containing the texture, you'll notice there's a translucency scattering texture. As we saw earlier, my custom node group has a specific input for this texture type. Let's go to the custom texture option at the bottom. We'll enable it and verify that the keywords match the texture type we want to find. In our case, these keywords are perfect, so we'll stick with them. The Connect to setting controls where the found texture is connected. It automatically displays all inputs available from either your custom node group or, if you're not using a node group, from the principled BSDF instead. For this case, we'll choose Translucent Map and then return to the Import section. For testing purposes, we can disable the Skip Existing option so we can re-import it as a duplicate. Let's check how the material looks now. As you can see, a new texture has been added and is already connected. I also want to further customize the import process by automatically enabling the translucency map and setting this value to 1. Additionally, under the color variation panel, there's a seed socket that I want to populate with a random number. While we're at it, we can also slightly adjust the translucency. Let's go back to the settings and enable the custom attributes option to set the values I mentioned. Here's a brief overview of the custom attributes feature. This option allows you to decide which attributes should be set during import. The socket field determines which socket to target, and the drop-down displays all available inputs. For example, if I select the color socket, I can assign a specific color. Or if I choose roughness instead, I can set a numerical value. You're not limited to static values. You can use randomly generated numbers, whether whole numbers or those with decimal places. Alright, let's set the values I mentioned earlier. First, the translucent map. Then the seed socket. And finally, the translucency. Now that we've set everything up, we can do a new import. Let's see how the material turned out. All of the attributes have been set exactly as we wanted. Let's take a closer look at the custom texture feature again. This time, I want to highlight the Packed Texture option, which is useful if your textures are combined into a single file with different channels, such as RGB or RGBA. Some common packed textures like ARM and its variants are already handled by the add-on, but the custom texture feature can be useful for other custom formats you might have. For example, if your texture file has the red channel containing the roughness map and the green channel containing the metallic map, this feature will automatically extract and connect them to the correct inputs. To demonstrate how the add-on unpacks textures, we'll import an example that uses a standard ARM packed texture. Here, you can see the different channels being connected to their respective sockets. Notice that the texture includes a normal map in DirectX format, and the add-on automatically handles the conversion with this node. To wrap up this chapter, let's briefly explore the add-on preferences related to texture importing. To quickly access the add-on preferences, simply click the gear icon in the BatchGenie panel. Let's focus on the key settings. First, there are a few minor cosmetic options to make the shader nodes more readable. Next, you'll find general naming options that allow you to fine-tune how your textures are named. The traversing depth setting determines how many levels deep the add-on will search for subfolders when importing textures. You'll also find the texture detection tags, where you can edit the tags used to identify different texture types during import. While there are more advanced options available below, we won't be covering those in this video. For further details, please refer to the documentation on the website. Rendering asset previews. BatchGenie supports rendering previews for materials, collections, and objects, including VDB volumes. When it comes to rendering asset preview images, you have two distinct options. You can render through the BatchGenie panel, which makes it easy to generate previews in large batches. Or you can use the asset browser, which lets you specify which assets you wish to render previews for. When rendering via the asset browser, BatchGenie seamlessly handles both internal assets within the current blend file and external assets, so you don't have to open each individual asset blend file separately. This applies to all BatchGenie utilities within the asset browser as well. Let's start with batch rendering through the BatchGenie panel. First, we need to choose the type of asset we want to create previews for. For this demonstration, let's select Objects. Next, we have the filtering section, where you decide which items to include in the rendering process. The options in this list vary depending on the asset type. Let's select objects marked as assets to target the existing assets within this blend file. Let's open the asset browser to the side to see which materials we are working with. Here, we can see some objects with Blender's default previews, which, as you can tell, aren't that great. The next option is the Refine selection, which allows you to further narrow down the render selection by applying additional criteria. For our demonstration, let's select this option to target assets that either don't have any previews or are using the low-quality default ones. This Refine filter is especially useful if you've already rendered previews for certain assets and want to avoid re-rendering them all. Alright, let's take a look at the settings that apply to rendering. Whether you're doing it through the BatchGenie panel or the asset browser, they're the same in both cases. Let's take a look at the scene settings. Most of these settings are straightforward and self-explanatory, but we'll quickly go through them. The light preset option allows you to choose between different worlds for lighting your assets. The first few uses sky texture, while the custom option uses your scene's world settings, enabling you to use custom HDRIs. The remaining options are Blender's built-in HDRIs. You can even add your custom ones to the list, like the ones I've imported from Polyhaven. Next, we have the Studio preset, which lets you select a background for your assets. When you choose a preset, the Studio settings box will appear, allowing you to customize the background. For now, we'll skip the Studio preset, but I'll cover it in more detail later. Here, you can also adjust the strength of the light preset and the saturation of the world background. By lowering the saturation, you can desaturate the HDR image, allowing you to keep its lighting effects without the colors influencing the appearance of your scene. And here are the rotation settings: sun rotation, object rotation, and lastly, camera rotation lets you reframe the shot without changing the lighting. Here's a tip: use the buttons next to the slider to adjust in 45-degree increments, either left or right. In the camera settings, you'll find a few additional options. You can adjust the camera's tilt to change the perspective, angling it up or down. You can zoom in for a close-up view or zoom out to see more of the scene. You'll also find settings for focal length and exposure. Lastly, there are camera override settings for more advanced framing. We'll skip those for now and revisit them shortly. The next section is specific to materials. Here, you can select which object is used when rendering the material and a few related settings. We'll touch more on these settings later on when we get to the materials. And finally, the section with all the render settings. Here, you can configure the render engine, aspect ratio, resolution, and other familiar Blender options. At the bottom, you'll find the output settings, where you can choose to save your rendered images either inside the blend file as asset previews, externally, or both. Alright, enough talk, let's dive into rendering. Let's do a test render to see how things look with these settings. It's a good start, but I'd like to tweak the lighting a bit. Now, if we press render, nothing happens. It's due to the current refine filter, preventing rendering assets with already existing previews. To fix this, let's remove the filter so we can re-render these assets. Now that we've made that adjustment, you can see all the assets update with the new settings when rendering. Now, I'm happy with some of the previews, but I still want to tweak a few. To avoid re-rendering everything, let's check out the selection filter. We'll set it to selected objects so we can control which items get rendered. Let's select a few objects and render them. Some items could use a background, so let's experiment with the studio presets. If we go into Studio Settings, the first thing we'll see is the Material section. Here, we have a list of basic background materials, as well as an option to use a custom material. We also have some additional settings. The transparent backdrop makes the studio backdrop see-through, while remaining visible in reflections and bouncing light onto the objects. This way, the studio walls and floor can be used as reflectors to fill in shadows. The backdrop passes light option, which is on by default, allows light to pass through the backdrop, preventing it from blocking light from the world and casting shadows on your assets. While it's unlikely you'd want to disable this, the option is there if you ever need it. By default, the asset we're rendering will be presented flush with the studio floor. If we want to raise it off the floor, we can use this last setting to adjust its position. Let's test out the camera override function. With it enabled, we can use the view override to match the current 3D view's perspective. This allows us to precisely align our shots. Finally, disabling the auto frame function gives us control to capture close-up shots exactly as we want them. Let's try rendering some different types of assets. First, let's briefly review the collections rendering. It's quite similar to the object rendering setup, so there's not much new to cover. So let's dive in and do a render to demonstrate. Now, let's move on to rendering materials. In the filtering section, you'll find additional options. For this demonstration, let's choose marked as assets under the selection section. This option restricts the batch operation to materials imported through BatchGenie. For our demonstration, We'll disable this option since our assets come from mixed sources. Some are imported textures and others are procedural materials. Let's proceed with some test renders. Good start. Now let's modify a few of them. Let's render just a few selected materials and try a different material preview object. To do this, we'll change the filtering to materials on selected objects and assign the material to them. Let's start with our trusty friend Susan. Now, let's shift over to the asset browser. Rendering through the asset browser. The rendering setup here is similar, and you can access both render and scene settings through the BatchGenie menu. Rendering is straightforward. Just select the assets you want to render and click Render, sit back and watch the pixels fall into place. For convenience, let's keep the default BatchGenie panel open on the side for quicker adjustments. Let's test render all of these assets. These assets are internal to the current blend file, but it works just as well with external files. Let's open up an external library that consists of multiple blend files to test it out. As you can see, these buttons are grayed out, and we can't edit them directly without opening each file separately. With BatchGenie, we're able to process these external assets just as if they were internal. It looks good, but let's tweak the lighting and make a few more adjustments. I've added the render button to my quick favorites, which I can access by pressing the Q key. Great! Here are the results from this quick test. You'll see there are endless possibilities for adjustments, allowing you to customize the renders exactly to your liking. Utilities. BatchGenie provides a wide range of utilities to streamline your workflow. Let's start by going over where to find them. Most of the batch-focused utilities can be found in the main BatchGenie panel. For asset tagging and metadata utilities, head to the Asset browser under the BatchGenie menu. These can also be accessed through the right-click menu in the Asset browser. And finally, if you're working with materials, additional utilities are located in the Shader Editor's BatchGenie End panel. First, some quick tips. If you spot a question mark icon, click on it for helpful information. Additionally, all utilities generate detailed reports in the console, offering insights into the actions performed. Let's dive into the utilities in the main panel. Change node attributes. This tool allows you to batch modify attributes across multiple materials. It's perfect for making consistent adjustments to properties like roughness, metallic, or any other material attribute. These two options are frequently found in many of the utilities. This option restricts the batch operation to materials imported through BatchGenie. For our demonstration, we'll disable this option. The selection field, where we specify which materials to include in the batch operation. For now, we'll leave it set to all materials so that the changes we make will apply to every material in this blend file. Next, we choose the type of node we want to target. Let's start with shader node. This targets the main shader connected to the material output within the material. From here, we can modify any socket value we want. For example, if we want to adjust the roughness to a specific value, we simply assign the value here and click Batch Change. Let's open the shader editor to the side, so we can watch the updates as they happen. Let's click on Change. Now, as you can see, the roughness has been adjusted to the value we selected. We can also populate sockets with random numbers. The additive option lets you adjust values by adding or subtracting rather than replacing them. And we can also populate color sockets. Let's try it with the base color socket and pick a color. Maybe something dark, like black to match our coffee. Now, let's jump to the next node type, texture nodes. This option allows us to modify all attributes for every texture node inside the materials. These are the standard Blender settings, nothing too complex here. Let's go ahead and change a setting. And there you have it, everything updated. Next up is the displacement node. This option finds the displacement nodes in your materials, allowing you to adjust either the scale or the space. Our new value is in place. Moving on to the normal map node. This option locates all normal map nodes in your material and lets you set a new strength. And just like that, voila! The bump node works similarly to the normal map option. It allows you to set a new strength for all bump nodes. Finally, we have the special seed socket. This option finds all sockets in your materials that contain the word seed and fills them with a random value within a range of your choice. Let's first find a node group that has a seed socket and see it in action. Change material settings. Here, we can adjust many of the common material settings such as the displacement type. The settings I'm referring to are found in the N panel inside the shader editor. For our first example, let's change the displacement type. These EV settings are quite intuitive, just select your desired option and click Change. Now let's check out the last option. This one sets the viewport display color of the material to match the base color attribute of the main shader. Let me show you how it works. Here we have some objects, each with different colored materials, but in the viewport, they all appear gray, which isn't very helpful. After applying the change, you'll see the viewport color update accordingly. Replace shader nodes. This utility lets you swap out existing shader editor nodes with custom node groups. It specifically targets the main shader connected to the material output within the material. You can also access this utility in the shader editor to process individual nodes rather than in batches, allowing you to replace specific nodes, not just the main shader. First, we have the usual settings for selection, etc. The Keep Original Shader Node setting. Check this option if you want to retain the original node for manual inspection of the connections afterward. The original node will be moved to the side of the replaced node. Next, we have the selection for the node group itself. Let's open the shader editor so I can show you the material and the node group. Here is my node group. It doesn't need to be part of the material itself, it's just here for this demonstration. You can choose any node group available in your file. Now, we'll pick the node group from the dropdown. The custom attributes function is available here as well, allowing you to set specific values of the node group during its creation. For more details on this, check the importing textures section of this video. Now, we can click on Batch Replace and see what happens. As you can see, the principled BSDF has been replaced, and our node group is now the new sheriff in town. Let's do one more replacement to demonstrate how the Keep Original Shader node setting works. Let's start by restoring the material to its original state. Here, we can see the original node in its minimized state. Now, we can visually inspect everything to ensure it's all connected correctly. Find unconnected nodes. This utility helps locate materials with unconnected nodes in your file, like image texture nodes. You can choose the type of nodes you want to search for. Any unconnected nodes, only image texture nodes, or BatchGenie imported textures. The last option focuses on materials imported by BatchGenie that contain textures that couldn't be connected. In brief, when importing textures with BatchGenie, if there's an issue finding the correct connection for a texture, it will create a frame with reroute nodes, as shown here. This feature is useful after importing large batches of textures to ensure everything is properly connected. For this demonstration, let's focus on finding all unconnected nodes. Several utilities, including this one, share a common interface designed to find and display a list of materials. Let's quickly go over the shared buttons. The minus icon removes the selected material from the list. The trash can icon clears the entire list of materials. Note, these buttons don't delete the materials themselves, just their entries from this list. At the bottom, you'll find two Assign buttons. Assign to Object assigns the selected material to the currently selected object, allowing you to inspect it in the shader editor. Auto Assign automatically assigns materials as you select them from the list, streamlining the process. Now that we've covered the basics, let's hop into the shader editor and unplug a few nodes to demonstrate. With that done, we can click Search. The utility lists all materials with unconnected nodes. You can manually review each material, connecting or removing nodes as needed, or simply click Delete Nodes, and as the name suggests, it will remove all unconnected nodes. For this demo, let's start by manually reviewing a few materials. I'll enable Auto Assign to speed things up. Let's highlight the nodes to make them easier to spot quickly. After going through and deleting some nodes, we can hit Refresh Search to see how we're doing. Notice that as we deleted earlier nodes, additional unconnected nodes surfaced. Now, let's try the Delete Nodes function. Remember, it only affects materials on the list, so if there's anything you don't want to change, just remove it from the list first. And there we go, everything is cleaned up. Let's check what the console says to get a more detailed overview of what was deleted. You can also see the previous searches we've done listed here. Everything looks good here. Let's move on to the next utility. Find zero strength nodes. This utility helps you identify nodes with critical values set to 0, which can negatively impact your material's appearance. You can choose specific node types to check. For normal map and bump nodes, it flags any with strength set to 0. For displacement nodes, it checks if scale is 0. You can also access this utility in the shader editor to process individual materials rather than in batches. For our demo, let's select all node types. The interface buttons are the same as those in the Find Unconnected Nodes utility. If you need a refresher, check the previous section in this video. To demonstrate, we'll jump into the shader editor, set some values to 0, and then return to the utility. Now that we've run the search, we found our culprits. You can manually update each material one by one, or use the Set New Value option to apply the same value across all of them. First, let's go over how you can manually review each material. I'll enable Auto Assign to speed up the process. This feature automatically assigns the selected material to the object, allowing us to quickly review it in the shader editor. For this demonstration, let's set a new value. Everything looks good. And as always, if you need more details on the actions performed, be sure to check the console. Color Space Validator. The Color Space Validator is designed to ensure that the image textures in your materials are using the correct color space settings. It generates detailed reports on any issues found and offers an option to automatically fix these issues. The first thing you will see is the console option. You can choose between two levels of reporting: standard for a concise overview or detailed for an in-depth analysis. If you prefer, you can simply skip reviewing the report altogether if it's not of interest. The interface for this utility is similar to the Find Unconnected Nodes utility, so if you need a refresher on those buttons, be sure to check the previous section of this video. Let's demonstrate how it works. First, we'll head over to the shader editor and intentionally change some color spaces to be incorrect. Once that's done, we can run the search in the Color Space Validator. As you can see, the search has identified all the textures we modified. You can choose to manually update each material one by one, or use the Auto Fix feature to automatically correct all the texture's color space settings. If we go the manual route, you'll notice that BatchGenie has created these helpful node frames, making it easy to locate all textures with issues. But for our case, let's use the Auto Fix feature. And just like magic, presto! Our color spaces are corrected. Maybe I should start calling this feature Node Magic instead of Auto Fix. Batch Rename. The Batch Rename utility may not be an all-encompassing renaming tool, but it offers targeted assistance for specific tasks, particularly useful for imported assets. Currently, there are 2 renaming options, with potential for more in the future. Let's walk through these options with a couple of examples. Set mesh names, same as object names. Imagine your scene filled with meshes that have generic names, making it difficult to identify which mesh corresponds to which object. This option solves that by renaming the meshes to match their object names. In this file, I've imported a bunch of assets, and as you can see, the mesh names are quite generic. Let's rename them. Now, the meshes are named after their respective objects. Set image names same as image file names. After importing external models, you might find textures with generic names like base color or roughness, which can be confusing, especially if you have multiple textures with the same name. This option renames those textures to match their actual file names. I have imported some assets, and as you can see, the textures have generic names. When we check their actual file names, they're more descriptive. Let's fix that. Now, the textures have better names, making them easier to identify. Reload images. If you've made changes to your textures externally, and those changes aren't showing up in Blender, the Reload Images utility is here to help. It refreshes all the images in your file to reflect any updates. There's not much to it, simply press Reload and you're all set. Clean File. The Clean File utility removes temporary files and data that may be left behind if Blender crashes during a batch process. Typically, you won't need to run this manually, as BatchGenie automatically detects and prompts you to clean up after a crash. You can also use this utility to remove extra info nodes that BatchGenie has added to your materials by selecting the Material Info Nodes option. These nodes, like frames or reroutes with notes, don't affect your materials, but can clutter your project. For further details, please refer to the documentation on the website. Shader Editor Utilities. In the Shader Editor, you'll find variants of some of the utilities available in the main BatchGenie panel. Replace Node. The Replace Node tool functions similarly to the Replace Shader Nodes utility but focuses on individual nodes instead of batch processing. It allows you to replace any type of node, not just the main shader node. For a comprehensive overview, check out the Replace Shader Nodes chapter earlier in this video. Here's a quick demo. First, choose whether to replace the main shader or a specific node by choosing Active Node. Let's select the main shader and pick a node group from the replacement list. First, let me show you the replacement group. Since our group has a seed socket, let's go ahead and populate that as well. As you can see, the principled BSDF has been replaced. Now, by switching to the Active Node option, you can select any node within the material and replace it with your chosen node group. I want to replace the Ambient Occlusion Mix node here. Let me show you the replacement for it. Let's select the node and disable the custom attribute we set earlier. And now the Mix node has been replaced as well. Find Zero Strength Nodes. This utility mirrors the functionality of the Find Zero Strength Nodes tool from the main panel, but is tailored for individual materials. For a detailed walkthrough, check the main Find Zero Strength Nodes section of this video. Here's a quick demo. Let's select all node types, set some nodes to 0, and then perform a search. The list below shows all nodes it finds. If we have trouble locating a specific node, we can use the highlight function to make it easier to spot. Now we can either manually set new values for each node or use the slider here to adjust the value for all found nodes at once. Now everything is updated, and the utility doesn't find any additional issues. Asset Browser Utilities. Let's explore the BatchGenie utilities available in the Asset Browser. You can access these tools from the BatchGenie menu at the top or via the right-click menu. All the upcoming demonstrations will use both internal assets within the current blend file and external assets from multiple blend files to showcase the seamless integration. Add asset tags. Add tags to your assets. Simply select the assets you want to tag, choose the desired tags, and BatchGenie will handle the rest. You can use default tags or smart tags, which automatically assign properties to your assets. First, let's add a few default tags. You can either create new tags or copy existing ones from the selected assets. Let's add tags to these assets so we have some tags to work with. Now that we have a bunch of tags, let's test copying them. First, select a group of assets. Next, use the drop-down to choose from the available tags on these assets that you want to copy. All done, now the tag has been duplicated to the assets. Next, we'll explore smart tags, which retrieve specific properties from your assets blend file and apply them as tags. Let's start with the object triangles tag, which labels object assets based on their triangle count. Let's customize the formatting and rounding options. Let's go with this format and apply the tag. As you can see, the tags were applied only to the relevant assets, objects in this case, even though we had other types of assets selected as well. Next up is the Object Vertices tag, which shows the vertex count of object assets. As before, select the assets you want to tag and access the menu by right-clicking inside the asset browser. Let's adjust the formatting to our liking and apply this tag as well. Then we have the Object and Collection Dimensions tag. This tag displays the size or dimensions of objects and collections. Let's select some objects and collections. You can choose either of these options, and you can change the type in the next step if needed. Let's tag both objects and collections. We have a variety of formatting options available. Let me walk you through some of them. Let's go with these settings and apply the tags. Finally, there's the Material Texture Resolution tag. As expected, this tag shows the texture resolution of material assets such as 2K, 4K, or 8K. Let's apply this tag and see the results. Updating Smart Tags. Smart tags overwrite any previously applied tags of the same type. For instance, if you've added an Object Dimensions tag and later make changes to the object, you can reapply the tag to override it with the updated dimensions. This ensures your tags always reflect the most current information. Additionally, you can update the formatting of the smart tag by simply overwriting it. Combine and split asset tags. This utility allows you to either combine or split existing tags on assets, making tag management more flexible. The combine function merges single word tags into a single line, separated by commas. Conversely, the split function separates combined tags that are formatted as a list, returning them to individual lines. It's important to note that tags with spaces won't be affected by either function. Now, let me show you how it works. First, we have assets with single tags, each on a new line. Let's combine them into one line. Let's combine these as well. And now, let's use the split function to reverse it. Remove asset tags. This utility allows you to remove tags from your assets, offering 3 different modes to do so. The first mode, Existing, displays all existing tags from the selected assets. You can pick the tags you want to remove from a drop-down list. There's also a filter that lets you choose to display only common tags, or tags that are not common across all selected assets. Let's go ahead and delete some tags. The next mode is Keyword Search. Here, you simply type in a keyword that matches the tag you want to delete. You can refine your search using options like exact, contains, starts with, or ends with, and there's even a case-sensitive option for precise targeting. For example, I have a tag that says Hi Polly. I'll use the contains option with the keyword Polly and click OK. As you can see, the tag has disappeared. The final mode is the Smart Tags Remover. This feature lets you specifically target and remove smart tags applied by BatchGenie without affecting other tags. Let's remove the triangle count tag from this tree. Let's remove some of those dimensions tags we added earlier. Success! Asset metadata. This utility lets you add important metadata to your assets, including description, license, copyright, and author information. You can select and edit one or multiple attributes simultaneously, making it easy to update your assets' details in bulk. Now, let's test it on multiple assets. Works like a charm. If you need to edit existing metadata instead of adding new data, you can simply select a single asset, click the Retrieve button, and it will pull up the current data for you to edit and save. Move assets. This utility allows you to efficiently move assets between different asset catalogs, helping you better organize your asset library. Let's walk through how to use it. First, make sure you're in the specific asset library where you want to move your assets. We are currently working with assets from both a current blend file and external blend files. If the assets are internal, you can simply drag and drop them wherever you want. But with external assets, you can't just move them by dragging. To fix this, we'll use the Move Asset function. First, let's select the assets we want to move. Then, we'll choose the appropriate category. Use the asset library on the left as a reference. With just a few clicks, you can transfer them from one catalog to another. Without BatchGenie, you'd need to open each blend file individually and manually move the assets. As for how it works, the utility doesn't alter the asset's physical location, it simply changes the catalog ID they're linked to. This makes the assets appear in the designated catalog, just as if you had manually moved them yourself. Preferences. Here's a brief overview of BatchGenie's preferences. To access them, click the gear icon in the BatchGenie panel. Let's begin with the General section. We've already covered import texture settings earlier, so refer back to that chapter for more information. In MISC settings, you can choose whether BatchGenie appears in its own End Panel tab or within the Tool panel. This helps manage space if the End Panel is crowded and affects the Shader Editor tab as well. And now, let's move on to the Advanced section. Under Advanced MISC settings, you can adjust the External Asset Processing Max Threads. This setting determines how many parallel processes are used when handling external assets via the Asset Browser utilities. Specifically, it controls the number of background Blender processes that run when you add tags or metadata to assets located outside the current blend file. Adjust this based on your system's capabilities to optimize performance for processing external assets. Note that this setting does not affect rendering performance, as the rendering process itself is the main bottleneck. For a deeper dive into all available options, please check the full documentation on the website. Thank you for your interest in learning more about BatchGenie. I hope you found this tutorial informative and helpful. If you have any questions or need further assistance, feel free to check out the documentation or reach out.